Hello, this is the course Optoelectronics, taught for the third year license telecommunications, and I am Professor Farid Boutout. This presentation concerns Chapter 2 of the aforementioned course. It is titled Cable Types and Applications. Now, we will focus on the different types of fiber optic cables. There are four categories of applications in which fiber optic cables can be classified: aerial cable, underground cable, underwater cable, and outdoor cable. The special properties required for each of these applications are taken into account. Note that the list is not complete or exhaustive, and that some specialized cables must combine the characteristics of several of these categories. Firstly, the aerial cable. Aerial cables are literally exposed to the elements more than any other application, such as and they are exposed to many external forces and hazards. Aerial cables are installed between poles, with the weight of the cable continuously supported by usually a steel messenger, while to which the cable can be directly lashed or by the strength member integral to the cable construction. The effects of combined wind and ice loadings can produce greatly increased tensile forces. Conditions are the wide variations in temperature to which the cable may be subjected, affecting the physical properties of the fibers and the attenuation of the fibers. The longitudinal cable profile is important for reducing the wind and ice loadings of such cables. Moisture barriers are essential, with jelly-filled, loose buffered fiber cable configurations predominating. Any water freezing within the fiber housings will expand and could produce excessive bending of fibers. The cable shell material is required to withstand the extremes of temperatures and the intense ultraviolet light exposure from continuous exposure to sunlight. Ultraviolet stabilized polyethylene is frequently used for this purpose. The installed span, length, and sag requirements are important design parameters affecting the maximum cable tension. They also dictate the type of cable construction to be used. Short span cables have less stringent tension requirements, which can be met by the use of integral Kevlar layers, whereas long span cables may need to utilize multiple stranded FRP rods to meet the required maximum tensions. Self-supporting cables. These cables have a separate messenger wire, that is a supporting wire, usually in steel, which can be clamped to the support structures on the poles to carry the tensile forces on the cable. The construction of the cable is illustrated in Figure 1. The separate messenger wire facilitates installation. So this is the structure or the cross-section of the self-supporting cable. Short span dielectric. Span means, in this case, the length. These cables use non-metallic strength elements. They have peripheral Kevlar layers and a slotted core to use FRP strength members. Such cables allow spans up to 150 meters, with maximum allowable tensions of around 300 kilograms. The construction of these types of cable is shown in Figure 2. So this is the figure of short span dielectric cable, a cross section of which, of course. We have another type, which is a long span dielectric or a long length dielectric. These cables also use non-metallic strand elements. They consist of a peripheral layer of stranded FRP rods and a slotted core with FRP strand members. Such cables allow spans up to 1,000 meters with maximum permissible tensions of around 1,200 kilograms. The construction of this type of cable is shown in figure 3, the following figure. So herein we have a cross section of a long span dielectric cable. Let's talk about the advantages and disadvantages of IRL cable. Firstly, the advantages. So the first item is they are useful in areas where it may be very difficult or too expensive to vary the cable or install it in ducts. Secondly, they are also useful where temporary installations are required. Now for disadvantages, we have that the system availability is not as high as for underground cables. Storms can disrupt these communication bearers, with cables damaged by falling trees, storm damage and blown debris. Roadside poles can be hit by vehicles and shooters. The underground cable. The underground cables experience less environmental extremes than aerial cables. Underground cables are usually pulled into ducts or buried directly in the ground, with the cable being placed in a deep narrow trench, which is backfilled with dirt or else plowed directly into the ground. Metallic moisture barrier. This incorporates a longitudinally applied polymer-coated aluminum laminate, which is bonded to the inside of the polyethylene shed. The tape is closely formed around the cable core and the overlap welded by melting the polymer with hot air. This hermetically seals the core against water entry through the thread. This is a cross-section of the metallic moisture barrier cable. Now the advantages. So they are usually the most cost-effective method of installing cables outdoors. Secondly, greater environmental protection compared to IRL cable. And thirdly, usually more secure than IRL cable. Now for the disadvantages, we have firstly, they can be disrupted by earthworks, farming, flooding, etc. Secondly, rodents, which are animals such as, for example, rats and mouse. Beating cables can be a problem in some areas. This is overcome with the use of steel tape armor or steel braid, or the use of a plastic duct of more than 38 millimeters outdoor for all dielectric cable installations. In addition, the use of Teflon coatings on the shed makes the cable too slippery for a rodent to grip it between its teeth. That's amazing. Now, another type of cable is subaqueous or underwater cable. So, subaqueous cables are outdoor cables designed for continuous immersion in water, while the most sophisticated cables are used for deep ocean communications by international telecommunication carriers. There are practical applications for subaqueous cables for smaller users. These include cabling along or across rivers, lakes, water races, or channels where alternatives are not cost effective. Subaqueous cable is a preferred option for direct buried cabling in areas subjected to flooding or with a high water table, where, for example, if the cable were buried at say 1 meter depth, it would be permanently immersed in water. This is a cross-section of a subaqueous cable or underwater cable. The advantages of subaqueous cables. Firstly, they are cheaper installation in some circumstances. For the disadvantages, it is unit cost of cable is higher. So the cost of the unit meter, if you want, or unit length is higher than other types of cables.